My talk today, from the title, seems less programmatic than the ones we've had before, but there is a similar degree of programmicity to what I'm going to say. I want to establish that my talk is just about two claims, which are very simple. The first is that Alice Kober was equipped to decipher linear B, and the second is that we as a discipline should care. It's an example of linear B. For people who are curious, there is the word process. The structure of the talk is going to be that I'll give you the historical context, so the discovery and decipherment timeline, Kober's contributions and opinions of her. Then I will set this in a bit of intellectual context. This is where it gets programmatic, where I'll talk mostly about my own recent work and where I hope to go with it. And then I'll get to my central claim, which is simply what it says there. Grids plus homologs, Cypriot homologs, equals decipherment. It's slight simplification, but that's the basic idea of the talk. Two elements are enough to have pushed Kober towards a decipherment. I'll then tell you what those two elements actually mean, the grids and the Cypriot. You may have heard of Kober's triplets, for instance, or triples in some literature. And the homologs, they're characters that are similar on Crete and in Cyprus. Then I will look to how we could have expanded, brought the two elements together, expanded what Kober actually published, how she herself expanded in an unpublished work. And hey presto, we will get to what looks pretty close to the beginning of a decipherment. So we will have pursued a method that ignores sound, but creates a structure in which sound-like properties immediately become apparent, become self-evident. The last thing on the slide, so Kober's methods would have brought sound to the script, a success previously attributed uniquely to Ventras's inspired guesswork. So there's an historical corrective in this talk that it wasn't just Ventras taking really clever guesses that was the only path to decipherment. There were other ones. Do I need to take care of the little things? Okay. Okay. Alice Kober was born in 1906. She died in 1950. Her reputation rests on the works, well, the entirety of her output, I believe, are the works on screen. So easy to overlook such a small CV. The works in black are the chief ones in which she contributed to the decipherment of linear B. I'll say a bit more about them, I think, in a bit. There's one edition at the end, which is 1952, Arthur Evans, the second volume of Scripta Minora, edited by John L. Myers. You will notice Alice Kober's name does not appear in there, and it probably should. The reason that it was as coherent and as useful as it was is because she spent her dying months really bringing order to it. Despite her publications, doubt has been cast on Kober's ability to have deciphered linear B. Ventras and Chaddick, who published what became known as the Mycenaean or the Linear B Bible, refer to her prim but necessary program and rather ponderous logic. I mean, they also devote a third of their brief description of the decipherment process to her work. So it's not like it's all insults or she's been overlooked, but there are a couple of value judgments in there. Andrew Robinson, in his biography of Ventras, says that she was too restrained to have cracked it, somewhat spoilt her key insights, and to go further would require willingness to take intellectual risks, the implication being that she didn't. Margaret Fox, in her biography of Kober, says that Kober was cautious, yes, but she did show willingness to experiment, particularly in unpublished material, but she still joins this, there was a mistake she made, and that's how Ventras pulled ahead. Just briefly, when you actually read her papers, so never mind what she didn't publish, when you read her papers, there is real willingness to experiment in there. Her first paper, the 1944 one, is an experiment in pragmatics. Can we figure out what's going on between texts that occur near one another? Then in 45, she turns that into an ability to recognize repeated words and their functions. Then she turns that into analysis of morphology in 46. Then in 48, she turns that into an analysis of sounds that must be shared between signs, even if we don't know what they are. And then the one that I really like that gets overlooked is that in 1949, she goes back and sets on firm footing what were just scattered asides and a few footnotes in the 44 paper. So in other words, she committed herself to experimental thoughts in 44 and then delivered on them 5 years later. There are two fallacies, I think, in the assessment of her. There's a minor one, but I think in the interest of time, I'll just skim by. The major one is that when we ask whether Kober could have deciphered linear B, we are not asking whether she could have produced Ventris's decipherment. We need to ask a different question, namely, of all possible decipherments, were any accessible via Kober's methods? And I believe the answer to that is yes. Um, so why is this a question worth asking? So you want to cite a talk that I hadn't heard at the time I cited it, but there's the intellectual context is that so I've been working on decipherment now for a good few years and finally have something to show for it, available in all good bookstores from October. We as a discipline sit on a wealth of data that ought to be appreciated and studied by other disciplines. And three of them are philosophy of science. We lack a theory of decipherment. We have good descriptions, we have good typologies, but we don't actually have a theory of what goes on when people decipher. And so understanding how decipherment could have worked, not just how it did work, is important to that. There's also a history of science question. Decipherers from around the world, even when they don't talk to each other, even they work on different scripts for different languages written in different materials, converge on the same methods. And there's an anthropological point, which is writing systems structure as a poster child for convergent cumulative cultural evolution. I know we have an anthropologist there, so I don't want to be insulting, but the way that anthropologists argue for writing as convergent cumulative cultural evolution, gosh, that's difficult to say, is in terms of its effects on society, not on the internal structure of the script. And that's really where decipherment and our field as a whole has something to offer. How am I going for time? I started at 1:30, is that right? Okay, I think I will skip I think I'll just, yeah, so I may come back to these if there's time. Yeah, some specific examples. Okay, let me get to the nub of the matter. The claim that I want to make is that grids plus homologs equals decipherment, and Kober was in the position to do the first two, and therefore would have been led naturally to the third. To explain what the grids are that I'm talking about, I want you to think of root affix combinations first in a familiar case, English. So if we take roots like silk, wool, earth, and wheat, we can add endings like ear, east, and n to them to end up with silkier, woolliest, earthen, and so on. I've colored the syllables. I've broken those words into syllables and I've colored them. The gray ones have a unique origin. So they either come wholly from the root, or they come wholly from, so sil belongs to silk, wool belongs to wool, or else they come wholly from the affix. So belongs to er, est belongs to east. We can call these non-juncture syllables and juncture syllables. So the juncture syllables are in black. They arise at the juncture of the root and the affix. Non-juncture syllables are invariant in the little graphic that we're looking at. So either within the column, it's sil, sil, sil all the way down, or if you're looking at the suffixes, it's all the way across. The juncture syllables are non-constant. However, so it's ki, ki, kun, so there's variation there, or if you go across, it's ki, li, fi, ti, there's variation there as well. However, within each column, the juncture syllables alliterate, ki, ki, kun, li, li, lun, and so on. And within the rows, they rhyme, ki, li, fi, ti, kun, lun, tun, tun. This is what Kober realized when she was looking, once she'd realized that she could find roots and she could find affixes, she realized there was this bit in the middle. And if you could organize it the way that I just showed in English, then going down the columns, you would get alliteration. Going across the rows, you would get rhymes. So you would know, without knowing the actual sounds, you would know what sounded alike. This is something that happened in other decipherments. Oracle bone Chinese was largely done in silence. Large parts of ancient Egyptian decipherment and demotic and hieroglyphs were done in silence for a long time. There are other examples. Hincks, when he was working on the Akkadian of Lake Van, same thing, figured out the regulated system, but he just didn't know what anything sounded like. So if we take this diagram here and get rid of all the extraneous information, so the gray cells and the repeated cells, then we get the following grid. And this is what Kober published in 48. When decipherment came, it would prove that she was completely correct. You will see underneath that all the columns alliterate, si, so, ti, to, all the rows rhyme, si, ti, ni, mi, wi. That's the first ingredient. The second ingredient is that there was a deciphered script, Cypriot, which looked kind of like, it had a few symbols that looked kind of like a linear B. And in the interest of time, we'll just go down to the bottom left of this page, no, bottom right, sorry, of this page, and say that the 8 symbols that I've highlighted are the ones that would have been the ambient hypothesis at the crucial moment if Kober had been able to continue when there was more data about. Attention has recently been drawn by the classicist Thomas Palaima to Kober's notebooks, which have only recently become available, where we see that she pushed beyond the grid that we just published, the 10 characters top left in the little table, and actually kind of doubled the amount of the number of characters that she was trying to slot in. I don't have time to enter into it. You can see there are mistakes, like new occurs in 2 places and it's on the wrong row, the wrong column. But there's a lot of good insight, like and you can see that she's beginning to get this bit of the system to work out. B looks a lot like A, so this is probably a reading mistake. So that she was still trying to figure out which characters were the same. Oo and wo, if you know any linguistics, you realize that's actually a kind of a clever, linguistically insightful mistake to make. So she herself was pushing beyond, the cliched lack of hypotheses, lack of willingness to experiment. So the question is, if we imagine her doing this at a time after her death, where within 2 years, 2 major studies of data became available to which she'd only had limited access beforehand, what could she have done? So to run this experiment, I took the resources you see bottom here and just looked within the same lemma. So I don't want to take the whole decipherment and then say, oh, look, if you assume the decipherment, then you can reconstruct what you might have done. That seems a bit silly. So I'm trying to use a much more restricted set of data somehow to imitate the kind of situation she would have been in. That restriction actually rules out some of the data she used, so it's quite a restrictive one to impose. Nonetheless, when you do it, you find a lot of alternations, such as, elephant with ta te to, I don't know what that one means, with ta te to, a te to alternation, ta to alternations, and when you add them all up, how to do this? Okay, so first thing, so you get lots of alternations like that. You get se si alternations, se so alternations, so lots of alliterations for s's. For n's, also lots of alliterative pairs, na no, actually, and some nes as well, and ra ro ri. So again, if you can isolate the root and then look for inflections of it, you can see lots of cases where we're probably dealing with the same onset, the same alliteration, and different rhymes. If we slot these into the table, then, so for instance, have I written this down somewhere? No, I think I excluded it for. So in the earlier table, T and To, which come from one data set, and Ta and Te, were separate in different columns. Once you look at the data that I showed you, it forces these into the same column. Se hadn't yet been slotted in, but we now know it iterates with C and So, even if we don't know what the sound is. And so on. So you could have expanded the grid in the way I just showed you. And then the the Cypriot signs become crucial. Sorry, and I should say I'm skipping over something methodologically a bit contentious. If you spot it, I'm happy to talk about it. I'm not pulling a fast one on you. So the crucial thing is the underlying signs here are the ones from Cyprus. So the ones that in linear B look like Cypriot signs. So now imagine you're looking at a load of different signs, and the only ones you can read are the underlined ones. You would suddenly see that ta, ti, and to are in the same column, exactly as you would want if you were building this grid for Cypriot. You would see that to and ro, and I haven't done it, but also no, are on the same row, exactly as you would want if you were building the grid for Cypriot. So, no, I won't jump to that. So in other words, just extending Kober's methodology leads to a grid in which signs with known sounds are in the positions they ought to occupy. And so if you then begin to feed those sounds in, you get many of the sounds of the grid just popping out for free. Now, is this a crazy experiment to have done? I don't think it is. So I've got like 2 minutes left. Okay. Kober's grid was, the published grid was only 10 characters large. When Ventris picked up her methodology and began to run with it over a 2-year period that ultimately led to the decipherment of the script, his first stab at a grid really rode roughshod over what she'd done. He took guesses at sounds, he pulled things apart, and he lost the accuracy of the grid, went down to below 50%. Then he kind of got back on track, stopped thinking about sounds, expanded it further, and his second iteration of the grid had all of her sounds in the right places again, but also began to introduce the characters, the Cypriot characters. And he stuck with that structure through the third and final iteration of the grid. What's interesting, though, is that Ventris explicitly says that he avoided using Cypriot signs and their values as a guide. And I think we can trust him on this because he was convinced the entire time that the place to look for guides to sounds was not Cypriot, which was used to write a variety of Greek, but Etruscan. He was utterly convinced that Greek was a red herring. So we had Ventris inadvertently applying this methodology, and I don't think anyone in the Linear B literature or in the decipherment literature has noticed that in running his methods and Kober's methods, he actually put all of the Cypriot signs in the places where they ought to be. So in conclusion, with Cypriot signs in the right position, Cypriot values could have been fed in, revealing over a dozen signs, the values of over a dozen signs. So Kober at that point would have found herself in the same position as Ventris or Champollion, sounding out words for which you had like, 80%, 90% of the signs, and then trying to guess at the last one, at which point someone with her Greek could not have failed. Oh, 5 minutes. 5 minutes to keep talking, or 5 minutes for? Oh, okay. I had a different time in my mind. I thought it was, well, never mind. I'm going to stop before the 5 minutes. The path to so her path to get to this point would have been different from Ventris's, but consistent with her own methods. And in consequence, doubts about her abilities to produce a decipherment are, I believe, unfounded. The reason that we need to pay attention to this is that if we want a theory of decipherment, we need to look at more than how facts played out. We need to consider how facts could have played out. The claim that not just Ventris's decipherment, but any decipherment of linear B required his flair and fancy and unorthodox way of going about things leads to an incomplete understanding of what's really going on in decipherment. And for a theory of decipherment, we need to be more objective. That's where I'll stop. Yeah, there we are.
More really You know, that Evans looked at it, oh, hold on, it looks like horse, and rejected that as a possibility, because it wasn't.
Yeah.
Do we have any sense of what her own beliefs were and whether she would have been handicapped?
That's really interesting. I've been looking at a different aspect of that question. The classic move, once you can do a little bit of reading, is to look for names, and that's how Ventris worked. And so I've been looking at the question of, would she have gone and looked at names? And I think the answer to that is definitely yes, because right from her early work, the ones that I put in gray, where she's gathering, like the Inthos paper, she looks for words that we might expect to occur, but she also says in numerous places, we'll find names. Names are the things that we'll recover, and that's really what this literature might bring about. I would need to go back and look at, it would probably be her 44 paper, the gray 44 paper, that, or else maybe her 48 paper. It's a good question. I don't have the answer. Yeah.
Interesting. So, I gather it correctly, you're basically saying that if she persisted a little bit more and been a bit more careful with the research, she could.
Unfortunately, it's if she'd been a bit less dead. So I didn't read out the thing, but I mean, in terms of decipherment history, you've got Koba in 1950. So you see she dies just before the publication of Pile's tablets and Scriptum 2. So she died of cancer at 43, Ventris died in a car crash at 34. So in terms of the field, we benefit from people who made their contributions kind of in the nick of time. It's slightly hair-raising. Because I say that there are other cases where it's not death that got in the way, it's politics. Like 4 years ago, I presented a paper on Orkablad and what he could have done with the hieroglyphs of the Rosetta Stone. And I think it would have completely changed where decipherment went. But the people in Paris didn't want him having access to the papers. His government sent him somewhere else. And so there's just multiple political tensions that stopped him doing work that he really ought to have done.
How do we know that this decipherment is correct? Because my computer scientist intuition is, you give me all your corpora, I take all the words that are pragmatically relevant to the situation of the written utterance, and maybe I can find other decipherments that are fully relevant. But how do we know that that one is the right one and there couldn't be another one?
Yeah. Can I just say, I think it'd be great if somebody did that, because what we need as a field is some kind of talisman against these pseudo decipherments where somebody says, I'm going to take this as a guess as to what this text means, and then they continue with guesses, always creating a self-consistent system. And then at the end they say, wow, the system is consistent. That can't be coincidence. But yeah, it is coincidence. Well, it's not coincidence. The researcher has created the consistency. So these are people looking at themselves in the mirror and not recognizing their own reflection. And I've often thought that doing what you said would be the best cure for that. Not that I'm sure they would read the literature, but anyway. In answer to your question, Linear B is unique, I think, amongst decipherments in having absolutely no bilinguals at all. So the way that we normally figure out whether a text is right is that we've got some kind of comparator text. And there are places where it's easy to make the comparison. And so that's where the decipherment starts. In Linear B, that didn't exist, which of course is unsurprising because these were internal accounts and you don't produce bilingual accounts. So everybody working in the accounting department speaks the same language normally. What we have though is bilinguals based on pictures. So there are some really stunning tablets where there are, well, like the polo example that Amalia brought up, where you've got pictures of horse heads and you've got two signs that look like, you've got two signs, full and roll or low, same sign for both, that look like Cypriot. So you can take your Cypriot and just read the Linear B, and you've got polo next to a horse. So why didn't Evans want to play polo? I don't know. Maybe he knew from the Trojans that you shouldn't look Greek gift horses in the mouth, or something like that. But that
was symbolic of something else.
Yeah, it's possible. Right, from one word, you definitely shouldn't infer that, oh yeah, we're looking at a variety of Greek. But when you've got a picture of a tripod and you've got tiri pode, you begin to think, okay, this, and then on the same thing, you've got que toro we for a four-handled thing and ano we for a no-handled thing, and the pictures are giving it. This is basically a bilingual at this stage. So it's bilingual, but without the ling. We need some word for it. You're good at inventing labels for things.
But maybe we can find an information theoretical proof of consistency of the system.
I think that'd be, I mean, maybe not so much for this system, but I think in general that'd be, when you say we, who's we?
Information theoreticians.
Can we find some? Because
computer scientists.
I spent a period running into computer scientists and saying, have you got a grad student who wants to work on this? And they said, no, if the result is negative, it won't get them a job. But if you know some, yeah, I think this could be, yeah.
Oh, I was just gonna say, I was gonna ask about information theory too.
Mhm.
Kind of already answered it, but I think if you think about like, say linear reading, for example, if you didn't know it, you could get some sort of, oh, well, it's just random, right? It seems to me like a positive decipherment produces an interpretation that has like kind of like less entropy or something like that, right? Like, I mean, if you have like, if you like say you have encrypted text or something like that, and say, oh, well, it's here's my decipherment, but the decipherment is that the key is as long as the text, and it's actually just random noise. Not very satisfying the decipherment could be true. It seems like the verification condition here is like I don't know.
Yeah, I mean, you've got the entropy internal to the script itself, or rather internal to the text themselves. And then you'd have the entropy relative to the decipherment. And at that point, I just don't know how to run those computations. I don't know how to set up the problem. Yeah. Yeah, that's interesting. I don't know. I mean, that's like the picture bilinguals. I wonder whether there are cases like that.
I study Mongo and
Ah, yeah, I recognize your name.
Sort of something like that.
Which one?
Mongo.
No, which object?
Oh, it's one that Elton and Josh came up with recently. It's just a little shard. It has, I guess, 3 or 4 characters on it. But my best guess as to what those things would mean was I want to have written on a very small surface or something to textual with what the
Yeah. So if you can spot an abbreviation, even if you don't know the text, you can still say, "Oh, this is abbreviated."
It's like there was also, I don't remember the script or the context, but somebody I guess found an axe or whatever, and he was assuming it's the axe that.
Yeah, that was Ugaritic. Yeah.
Okay, to stop now. So thank you very much.
Thank you.